Hello, today we're going to talk about Lesson 47, and Lesson 47 has to do with powers of 10 and rules of exponents. To understand the rules of exponents, you really need to know the positive powers of 10, and these are really easy once you get the hang of it. 10 to the first power is 10 times 1, which of course is 10. 10 to the second power is 10 times 10, which is 100. 10 to the third is 10 times 10 times 10, which is 1,000. Now note that each time a number exponent goes up here, the number of zeros goes up there. So if you get to 10 to the fourth power, you can already see there's going to be a 1 and 4 zeros. 10 to the fifth would be a 1 and 5 zeros. 10 to the sixth, 10 to the seventh, etc. If you add 10 to the 100th power, it would be a 1 with 100 zeros. So those are the positive powers of 10. Now, it's just a note, if we multiply powers of 10, the exponent of the product equals the sum of the exponents of the factors. What's that mean? Okay, so 10 to the second times 10 to the fifth is equal to 10 to the 2 plus 5, which is 10 to the seventh. And if you look here, you've got 10 to the second, which is 100, 10 to the fifth, which is 100,000, 1, 2, 3, 4, 5, 6, 7. So that is 10 to the seventh right there. Okay? If we divide by powers of 10, the exponent of the product equals the difference of the exponents of the factors. So if you can see down here, it's kind of little. I should probably blow that up so you can see it a little bit better. Here, I'll move this so you can see it. 10 to the sixth divided by 10 to the second yields 10 to the 6 minus 2, which is equal to 10 to the fourth. And if you actually do the division, 10 to the 6 divided by 100, you end up getting 10 to the fourth. If you actually do the division. This is just a shortcut way to do it without having to deal with all of those zeros. So remember, if you are multiplying positive factors, you're multiplying, then you're going to add the exponents if you're multiplying. If you are dividing, you are going to subtract the exponents. Pretty simple rule, not too hard to understand. Okay, let's take a look at the third basic rule of exponents. If we raise a power to another power, the resulting power of the new number has a power that is a result of the product of the exponents. Okay, let's see what that looks like. So if we take 10 to the third power, I'll leave that there, and we raise it to the second power, notice the second is outside of the parentheses. So if you have a number with a power inside here, and then you put parentheses, and then you raise it to another power, you're actually going to multiply those two, and you end up with 10 to the sixth. And if you look at it and do the math, you'll see that it works. Okay? Now, this is something you've got to put in your notes. Got to put these in your notes, the rules of exponents. A to the x times a to the y is a to the x plus y. Example, 10 to the second times 10 to the third is 10 to the 2 plus 3. Okay? The bases have to be the same. Bases meaning these numbers. Okay? A to the x divided by a to the y equals a to the x minus y. So 10 to the third divided by 10 to the second is 10 to the 3 minus 2, which is 10 to the first. This has to be in your notes. This is an invaluable source when you're working with exponents. And lastly, a to the x raised to the y is a to the x times y, which is the same as 10 to the second raised to the third is 10 to the 2 times 3, which is 10 to the sixth. Now, we have some examples here where we have to find the missing exponents. I thought probably it wouldn't be a bad idea to look at these. You have 2 to the fourth times 2 to the seventh is 2 to the 4 plus 7, which is 2 to the 11th. 2 to the first times 2 to the 13 is 2 to the 1 plus 13, which is 14. 2 to the 6th divided by 2 to the 3rd is 2 to the 6 minus 3, which is 2 cubed. 2 to the 30 divided by 2 to the 15th is 2 to the 30 minus 15, which is 2 to the 15th. 2 to the 3rd raised to the 5th power is 2 to the 3 times 5, which is 2 to the 15th. Really important. Use it a lot. It'll save you tons and tons and tons of time. Okay, the other thing that we need to talk about today is expanded notation. And expanded notation can oftentimes get confused, so be sure that you understand what this is. In expanded notation, number 5,206 means 5,000 plus 200 plus 6. We will rewrite it using the powers of 10, and that is our expanded notation right here. So this example right here is expanded notation. So this is 5 to the 10, 5 times 10 to the 3rd, which is your 5,000, 2 times 10 to the 2nd, which is your 200, 6 times 10 to the 0. Anytime you take a number, any number to the 0 power is 1. So 6 times 1, basically, 10 to the 0 is 6. This is expanded notation, okay? And we are talking a little bit about multiplying with decimals, or excuse me, multiplying with powers. If you multiply times 46.235 or 46 and 235 thousandths times 10 to the 2nd, you are virtually just multiplying it times 100, right? So you move the decimal place 2 places to the right and it becomes this. Okay, here's another example. Write 2 3/4 in standard form, 2 3/4 billion in standard form. Okay, it's 2.75 times 10 to the 9th. And so then you just multiply it. This is standard form right here. Standard form means how you would see it on any given day. Standard form. Like 196 is standard form. If I take 1.96 times 10 to the 2nd power, this is scientific notation. This is scientific notation here. Okay, expanded notation would be 1 times 10 to the 2nd power plus 9 times 10 to the 1st power plus 6 times 10 to the 0. Okay, that is expanded. This is expanded notation. So we have standard, we have scientific. Standard is 196 like this, scientific is like this, and expanded notation is like this. This last one is expanded notation. Okay? Alrighty folks, I hope that was helpful. And if you have questions, ask me in class.